Welcome to your weekly technical briefing for August 25th to the 31st. We've got a lot to cover this week, focusing on some really interesting strategic splits between Microsoft and OpenAI, a huge architectural shift in voice models, and some new research that's asking tough questions about how well these systems actually understand things. So let's get right into it.
Here's the plan. We'll start with the big moves from the industry titans. Then we'll look at how that tech is being turned into actual products. After that, we'll dive deep into the foundational research and we'll wrap up by looking at the all-important context of safety and society.
So first up, the Titans. We saw two major model updates that really show a parting of ways in strategy. You've got Microsoft bringing things in-house, and at the same time, OpenAI is pushing the limits of what's possible with real-time AI interaction.
So Microsoft just dropped MAI-1, its first really big homegrown model. And when I say big, I mean it. It was trained on a cluster of about 15,000 H100s, putting it right up there with the other frontier models. But here's the key detail. It's optimized for consumer queries. That tells us they're probably focusing more on speed and efficiency for everyday use, not just chasing the highest score on a benchmark. This is a huge strategic move toward independence, giving them direct control over their costs and performance, and it's a pretty clear hedge against their heavy reliance on OpenAI.
Meanwhile, OpenAI is tackling a problem that has plagued voice assistants forever, that awkward pause. You know the one. The standard way of doing things involves this clunky three-step pipeline. First, your speech gets converted to text. Then, the text goes to the LLM. Then, the LLM's text response has to be converted back to speech. Each step adds a little bit of delay, which makes a truly natural back-and-forth conversation almost impossible. Well, OpenAI's new GPT-realtime model just throws that whole pipeline out the window. It replaces it with a single end-to-end speech-to-speech architecture. And this is a massive architectural leap. Because it processes audio directly, the model can understand and generate things like tone, rhythm, and emotion, all the stuff that gets lost when you convert to text. So not only does this slash the latency, it opens up a whole new world of more human-like, expressive AI voices. Okay, so that's the underlying tech. Now let's see how these new architectures are actually being sold and used. The big trends this week are definitely specialized models for specific jobs and some really aggressive price wars, especially in areas like translation and coding.
Cohere is making a big play for the enterprise translation market with its Command A Translate model. And it's not just talk, they're showing new state-of-the-art results beating out models like GPT-5 on business-focused languages. But what really makes this appealing for big companies are two things. You can fine-tune it on your own custom jargon, which is absolutely critical for, say, legal or medical fields, and you can deploy it on-premise, which is a huge deal for data security and compliance.
Over in the world of code generation, xAI is coming in hot with Grok Code Fast 1, and they are absolutely competing on price. Look at this, 20 cents per million input tokens. That is incredibly cheap. A price point that low suddenly makes all sorts of large-scale automated tasks, like analyzing an entire code base or auto-reviewing pull requests, actually affordable for a lot of companies for the very first time.
Now, the output pricing is a bit higher, at $1.50 per million tokens. And that 7-to-1-ish ratio between output and input cost, that's not an accident. It's actually really smart. It's perfectly optimized for those agent-like workflows where you feed in a ton of existing code as context just to get a small targeted piece of new code back. It's priced exactly for how developers would want to use it.
And is this aggressive strategy working? Well, the data says yes. The latest consumer AI rankings from A16Z show Grok has already climbed to the number 4 spot, right behind the big guys. That kind of rapid growth really shows that bundling a powerful model into an existing app is a killer strategy for grabbing market share. And of course, Google is in the fight too, competing on both price and performance in image editing with Gemini 2.5 Flash Image. It just snagged the top spot on the LM Arena Image Edit Leaderboard, which is a big deal because that benchmark specifically tests complex multi-step editing.
We're talking about changes where the model has to remember what an object is across a whole series of edits. And at less than 4 cents an image, it's clear they're treating this like a commodity to get as many people using it as possible. All right, let's peel back another layer and get into the fundamental research and hardware that makes all this possible. We're going to look at some papers that question what these models really know and the kind of hardware it takes to keep pushing the envelope. I absolutely love this quote from a new paper out of MIT and Harvard. They're making the case that our AIs right now are like Kepler, not Newton. See, Kepler was brilliant at observing the planets and predicting what they would do next based on patterns in the data. But it was Newton who came along and explained why they moved with his universal laws. That's the gap they're pointing to, the gap between just matching patterns and having a true deep understanding. So, to actually test this idea, the researchers came up with something they call a deep comprehension metric. It's basically a new way of evaluating models that goes way beyond just checking for accuracy. It's designed to see if the AI can reason about what-if scenarios and handle situations it's never seen before, the kind of stuff that breaks simple pattern matching. And their findings? Well, they're pretty eye-opening. Even our best frontier models really struggle with these tests, suggesting their understanding is more brittle than we might think. Shifting gears to computer vision, Meta's new DNO v3 model is a powerful reminder that sometimes just going bigger really does work. By making the model 6 times larger and feeding it a gigantic data set of unlabeled images, they've set new records in tricky tasks like image segmentation and depth estimation. And this is a really big deal because it shows that you can use raw computing power as a substitute for the incredibly expensive and time-consuming process of manually labeling data, which has always been a huge bottleneck in vision research. Of course, these giant models need some serious hardware to run on, especially out in the real world on things like robots and cars. That's where NVIDIA's Jetson Thor comes in. It's now generally available, and it's built specifically for this kind of embodied AI. It delivers a 7.5 times boost in AI compute, which is exactly what you need to run these huge perception and control models right on a robot, all while dealing with tight limits on power and heat. Okay, for our final section, let's zoom out and look at the bigger picture. With all these incredible new capabilities come new dangers, and some really important questions about what this all means for jobs and the planet. A new report from Anthropic has identified a disturbing new trend they're calling vibe hacking. It sounds a bit weird, but it's basically AI-powered social engineering on steroids. Attackers are using LLMs to automatically sift through public information to build detailed profiles of their victims. Then they use the AI to craft incredibly personalized and psychologically manipulative messages for things like extortion campaigns. It essentially takes an attack that used to be very manual and time-consuming and lets criminals scale it up massively. Now on to the big question about jobs. We're finally starting to get some hard data. A new study from Stanford dug into job posting data and found a 13% drop in entry-level jobs for roles that are highly exposed to AI, like copywriting, paralegal work, and some programming jobs. This is a clear signal that automation isn't some far-off future problem. It's already starting to impact the job market for people just starting their careers. But it's not all about replacement. In education, for example, it seems AI is being used more as a helper. Anthropic looked at how over 74,000 educators are using Claude, and the #1 use case, by far, is for administrative stuff, like designing lesson plans. A full 57% are using it for that. This suggests teachers are using AI to offload the repetitive work so they can focus more of their energy on actually teaching in the classroom. Finally, let's talk about the elephant in the room, the environmental cost of training these massive models. In a really commendable move towards transparency, Mistral published a report on the carbon footprint of training its flagship model. Quantifying this is so important for the field. It's part of a growing trend to include not just performance stats on model cards, but also the computational and environmental price tag, which is critical for understanding the true cost of this technology. And that brings us right back to the central question from that MIT and Harvard paper. As our models get better and better, even beating humans on our current tests, we have to ask if we're even measuring the right thing. The real challenge for the entire research community now is to figure out how to move beyond simply measuring predictive accuracy.
We need new ways to test for genuine causal understanding. Because solving that evaluation problem, well, that's probably the most critical step toward building AI we can actually rely on and trust.